today we will talk about how machine learning and more concretely natural language processing can help us to make our tools better for actually writing the code. So before I actually start, I will briefly introduce myself. I'm Shota Elkanishvili. I work as a software engineer contractor at Microsoft, and I work on product of Bing.com, which is called Knowledge Card, and I generate interesting facts out of famous entities. For example, if you search for famous locations, famous people, you will find one sub-panel into Bing.com where interesting facts are placed. So yeah, I work on that with natural language processing, and I also am assistant lecturer at Kutaisi International University. Okay. I think many of you have heard this phrase, software is eating the world. And if we take a closer look, we will understand that if we could not imagine things where the code will be necessary, now everything is different. If you, for example, the first Windows had 1 million lines of code. The last Windows has 100 million of code, and even these days, cars has software which runs hundreds of millions of code. So more code there is, more bugs there could be, and more flexibility it needs to extend, because the larger the code is, it's really hard to update things. So it's really interesting problem to just how can we somehow improve in writing the code. And if we think closely, we will see that even though this, for example, these compilers are progressing, for example, IDs are progressing, we still write code the same way. So what I want to say is that some best practices we already have, design patterns, and nowadays we write the same code. But the problem with it is that so even though the technology is progressing, we still write same code. So somehow we need some tools, not only for just highlighting the keywords of the languages, but also to help us write better code with better design patterns, and with much less bugs. Okay, so software is really crucial for our society, and because of this, we really need to somehow create these tools. And these tools so before we actually start thinking about how can machine learning or some algorithms can help us to develop this and solve this problem and progress with these things, we should first think what is programming language. So what's the difference between programming language and natural texts? So when programming languages were designed, the first idea was to communicate with computers the same way we communicate to each other, but it was not as possible because we can talk and switch, for example, words. So we can switch order of words, and you can still understand what I'm saying. But if you use programming languages, everything is formal, everything is well defined, well structured. So it's formal language, which means it's mathematical. It's more of a mathematical form of language rather than just communication language. So yeah, this is the first things I want you to think about before we actually go on and think about other stuff. Okay, with data science and with all this thing, we know what big data is, but we also have the same phrase, big code, here. So as programs go on and websites go on and logs are more generated, we gather more data and we have big data. But if we also think about it, the more companies are created, or more products are created, more codes are also generated. And not only codes, but also metadata. So for example, when you create project, no one creates project with only one commit, right? You still commit, push, and also do something. So you also have metadata with commentaries, commits, documentation, etc. So we really have big code. So GitHub actually has its own archive, but it does not include code. It just includes the metadata, which is just how the repository URL, repository name, stars, and things like this. But some research created Git archive, which is public Git archive, which was generated for researchers, machine learning researchers, and they gathered almost 200,000 repositories, and they filter them out by 50 stars. So because they wanted to have software which would actually work and should not be some private project first year students generated, and it was 3 terabyte Git repositories in a matter of storage. It consists 55 million files and 16 billion lines of code. So it's really big data, but as it is in big data, there are some patterns, right? So in human behavior, you can find some patterns which can be used for machine learning and other kind of stuff. So what's the difference between machine learning and standard algorithms? So machine learning tries to find some kind of distribution and find some kind of patterns in it and then generalize it. So interesting thing is that if we say that code is deterministic, and we say that code, if you just switch something, the compilation error will come up. How can we actually find patterns? Or are there even patterns? Or if there are patterns, if it's deterministic, how can statistical model somehow generalize on it? So if it's deterministic, so there are really good questions that will definitely come up your mind if you think closely and deeply. But yeah, I will try to figure them out with you now. Okay, so what researchers came up was a naturalness hypothesis. So what it means? So they claimed that even though, for example, codes are deterministic and things like this, it's still written by humans. So what it means? So if you just take all the code and try to cluster them out, I cannot say it for granted, but from my point of view, if you cluster them, one cluster will be senior programmers' codes, and another clusters will be junior. So what I want to say with it, so most senior programmers will try to write code with idiomatic ways. So what I mean, they will use design patterns. They will use correct documentation. They will all, for sure, write comments on it. So, and will be clean and will be flexible. And if you take junior developers, the code most probably will be messy. So what I want to say is that even though it's deterministic thing and it's really hard to imagine what kind of patterns should there be, there's still patterns, because it's written by humans, and human tries to do things which are best, and they're best practices. So that's it. So now let's continue talking on naturalness hypothesis. So what it claims. So it says that software is a form of human communication. As we talk to each other, we also talk to machines. The first sentence claims that software corpora have similar statistical properties to natural language corpora. So that's the thing I just explained. Because it's generated by human, it has some kind of similar statistical distribution and all those properties. And statistical properties can be exploited to build better software engineering tools. So it's generated from first two, I think. So it means that because we have statistical properties, we can design machine learning algorithms which can then determine patterns in it. Okay, and then build better tools. So now let's look more deeply. Is text, natural language, and programming languages same? So let's see two clear differences between these two languages. So first of all, natural languages does not have limitation to be executable. So what it means to be executable in human way, right? But in actual programming way, it should actually run, right? And it actually should compile. So for example, if we just switch the arguments of the functions, so for example, the first type was int, and let's assume that the programming language is statistical type, so we do not have changing types, dynamic types. So if first argument is int type and second argument is, for example, char type, and not char will compile string type, and if you just switch them up, if you switch to each other, the compilation error will come up. But if I just say I'm Shota, and okay, not that way, but if you just off is one sentence and you just switch two words in it, you can still assume, you can still get what I want to say. Maybe it won't be grammatically correct, maybe it will be, but I think you can still get, or maybe I will just say some word with different pronunciation, or I will just write with misspelled word, but you will still get it. But it's not the same, especially if your task is to generate code, right? So for example, if you want to give them logic, for example, generate button which will be red or something like this, and it will generate some code which will have extra semicolon or something like this, it will not compile. So maybe you will understand the code, but it just is nothing. So this is the first difference, main difference. And second main difference is formality. Even though natural languages has semantic trees and those semantic ways, they are semantic, they're still not as formal as programming languages, because so there is syntax, right? For example, if you want to write in C, C++, or Java, you want to write, for example, int a equals to 3, and you will write a int equals to 3. It will give you compilation error. So it has strict syntax, and it just gives you a limitation how to write it. So one could say it's limitation, but one could say that it makes much more things easier. For example, to parse the whole language and etc. etc. So it has its both cons and pros. It just depends on what your task is. So and second thing is that programming languages are top-down designed. So what it means is that it's not designed so people are fitting the language and not vice versa. When you and natural languages are vice versa, because people actually change languages. So you may say that, for example, one could say that, for example, some things would be better if you write this way, and the actual owners of the code will change it. But I mean, in a whole way, some could just generate their own neologisms and still be valid. So that's the main difference between text and source code. But other things, they can still be divided to tokens. They can still be divided. You can still have some kind of patterns in it, and so they're really interesting similarities too. Okay, so now let's think about actual machine learning. So when you do machine learning, you know you have input and you have output, and inside you can have neural network or something, you want some statistical model or something like this. So when you work with text, it's more or less understandable what the input is. So you can, for example, if you have big text, you can have it three kind of level: character level, word level, and subword level. And what I mean, you can just take every character of the sentence and pass it to the model, and this will be the sequence which will be given to the model. Second thing is to just not split them by characters, but actual words. So somehow split them with space or something like this. And third one is subwords. So it means that, for example, if you go with word level tokenization, you will find a let's call it problem that if a new word comes up and you do not know that word, what will be the corresponding token to it? So it will be unknown token. So it's more or less problem. And with subword level, you can just convert them. So now let's forget about natural language and let's talk about programming languages. So what could be this input for source code? So we can still do the same thing. We can get characters, or we can get words, and I have slides for it. Okay, now let's think about token-based analysis. So, for example, character level return 1, and it's just return 1. Word level return and 1. Subword level return random variable. So this one is pretty easy to implement, but somehow, for example, if you take character level, it totally forgets about everything. So it's really bad idea to go with this way, because when you have return, you know that return is a thing in programming languages, so you want to have it as a separate token, not with RETURN, something like this. If you go word level, what's the point of naming something? For example, some would name variables Georgian names or something like this. So I can call variable my name, Shota, and what will be the word level, right? Because they will not have corresponding token to it. So subword level more or less seems good idea, but it still has problems. Okay, so this is a token-based analysis. So analysis, by I mean what could be an input to model? How model will evaluate and things like that. Let's forget about it for a minute. Okay, second thing is really interesting one. It's AST analysis. If you are familiar with programming languages and compilers, you will know what AST is. AST stands for Abstract Syntax Tree. So when you actually run code, it first compiles it to abstract syntax tree, and that's how it checks, for example, syntax errors. So this is one of the form which code can translate to. There are many interesting ones, but here, for example, we have just Java code. We just searches for one object in a list of objects, and if it equals, it just returns true. So it's something like contains. We can call the function contains. So actually, it is when you actually run the code, it will be translated to the second picture, which is here. So this is we can call it tree, we can call it graph, but of course tree is a type of graph. But so okay, we have this, but what can we do with this? So how can we pass it to, for example, neural network? So we know that neural network can have something list as an input or something like this, but this is not list. So how can I pass them? So one interesting idea is that that could come up in your mind is traversal algorithms like BFS, DFS, post-order, pre-order, in-order traversals. What it means is that you start from the root node and go to each node, and when you go to leaf node is the node which does not have children. Children are just nodes coming from this actual node. But it still does not give you a something. So one interesting idea is to just take one concrete node and no, not node, sorry, leaf node more specifically, and another one. So you choose just last layers of this tree, and you generate paths to it. So you start from one node, go to second node, and you generate paths. And of course, because it's tree, you only have one pass to it, and you have a vector, right? Because you have actual nodes, and these nodes are actual tokens because it's Boolean expression. It's this one is return, this one is block, this one is for each, something like this. So with this, you will have a list of tokens. But the second question is, how can you choose which two nodes which will describe the whole program? The interesting thing is that you have not. There is no necessity to choose only two. You can generate all of this one, then go through the neural network, and then merge those embeddings. And this is the first idea. Second idea is to not only merge them, but use attention, which gives you weighted coefficients. So, for example, this path will be much important than, for example, some other path. So it will give you a weights, and when you merge them, it will be much more informative. So this one is really interesting one, and one of the best papers which is written about programming and machine learning on source code is Code2Vec. If you are familiar with machine learning, you will know that there are many models, something like this. For example, Word2Vec in natural language processing, Wow2Vec in speech recognition, Image2Vec in computer vision, etc., etc. So we still in this field we also have Code2Vec, and I will give you a demo of it. Okay, so before we go actually to demos, which is from my point of view really interesting, I will just give you a briefly introduction to what could be solved by actually researching on this topic. First thing is code completion. So if you generate code, if you imagine code completion as a sequence-to-sequence model, so you have an input and you want to output. So this one is still and the interesting thing is that the most how to say these days the most appropriate approaches in machine learning is not unsupervised learning or supervised learning. Most famous is semi-supervised learning. So what it means? So you get the data without any labels, and you try to somehow make your own task. So make your own labels to solve something. So let's go from top to down. So if you want to have understanding of code, you need to have embeddings. If you want to have embeddings, you should have some kind of training process, because you just cannot just randomly choose embedding and say that it's a meaningful one. So you have to somehow generate it, train it. If you have to train it, you have to train it on some tasks, because that's it. So because you need to have feedback, and if you need feedback, it means that you have to have labels. And you can generate your own labels. For example, in natural languages, there is famous model BERT, which just takes whole data and does really interesting tasks. So it just masks, so takes one sentence, masks one word, and asks the model to predict what is a masked word. So if it's able to actually predict what's the masked word, it means that it can actually get the context, because you just cannot random word and put it there, because it will make no sense. So this way, it's really interesting. But in programming languages, it's much more interesting, because when you have text, it's really hard to come up with ideas like this to give tasks, so to somehow make your own task for training. And in programming languages, it's very simple. For example, you can have function, masks this actual name of the function. So more or less, the functions are named with meaningful names, right? And let the program decide what should be the name of the function given the actual code. So third thing is to also generate return type. Also, you can just mask each tokens. Also, you can have something like this. So most functions are commented. So take comment, take it as an input and generate code, or vice versa. Take code and generate comment. With this way, if the model will be able to solve this kind of task, it will have an understanding of what code actually does. Because otherwise there is no way it could generate code out of comment. So it's really interesting. So code completion is something like this. You get, so you have fully function. You can just mask the last token in function, take this whole function without the last one, and make model predict the last piece of code. Also, second interesting problem which can be solved is code translation. For example, if you're familiar with Android and iOS development, there is really problem in companies that, I mean, most of the time startups, that they want both kind of application on iOS and Android, and it's sometimes they use Xamarin or something like this, which is cross-platform and can generate code for both of them, or they need to hire developers for both languages. I mean Swift and Kotlin. And with this code translation, you can have Android code and generate to iOS and vice versa. So if this research will go to the stage where it really does meaningful and really good results, it will be really nice for people to just change programming language without any headaches. So third thing is bug location and fixing. It could be really hard topic, because sometimes the problem is in developers understanding of business logic. So if developer doesn't understand the business logic, how can computer make suggestions what is a bug, where is a bug, and how can you fix it? So with this in mind, there is really interesting research when you also give business logic as a natural language. So pass them as an argument, as a natural language, and the model tries to also get what business logic is and then fix the bug. So it's really interesting. The next ones are correcting conventions. So most languages has its own conventions. For example, in Java, naming is something like start with every other word is starting with capital letter. So in this, it could be solved without machine learning, but there is still research on it. And the last tree is really interesting one. So first one in this last tree is text to code. So you get a comment and you generate the code. Second one is code to text. You get the code and generate a comment. So what it does, and we will do the demo for that. So I will pass the actual code and we will generate the text corresponding to that. And third one is information retrieval. So how can you search it? So for example, if you are programmers, you are familiar with Stack Overflow, and it's really interesting how Stack Overflow finds actual code you want. So sometimes you do not search with natural language. For example, just array index or bound, something like this. You just copy actual compilation error and paste it, and it still finds it. So it's really interesting, and Stack Overflow uses really nice models which deals with the problem. Okay. And yeah, now it's time for demos. Okay, for today I have prepared 3 demos. So first one is code to BERT, as I told you. So code to BERT does something like this. So it needs input file is a Java source file, and it is some function, and the name is f, for example, and it tries to generate the function name. So it tries to get what it does, I mean the whole code, and then it tries to generate the name of the function. In this case, we can say it's maximum because it checks if a is larger than b, and if it's so, it returns a. Otherwise, it returns false. Okay, it needs some time, and yeah, just we have to wait maximum 2 minutes. If you have any questions now, you can ask. Oh no, we can have. You can say so L, and it will generate. So it told us that it's most probably maximum. So it could be called maximum. So we can, for example, change logic something like this. For example, we can have Fibonacci written, for example, or what can it be? So for example. If you have any ideas for demos, just tell me what function to write, and we can have it. For example, let's search element. Write function which search for element. Return false. And let's see if it will be able to generate. It generated contains. So more or less, it thinks that what this function does is it just checks it, and if you also see other variations, it more or less they are familiar to it. Also, for example, if you have any suggestions, just please tell me, and we will test on it. Try order. What do you mean by order? Sort. Sort. Yeah. Sort. Okay. To be honest, I don't remember what's the actual. So it should be something like array sort, something like. If I don't remember exact it. So it should return an int array and return array, something like this. Let's see. Yeah, sort. So output is sort. sorted, get, sort, find, all, yeah, sort description. So also, for example, can you repeat, sorry? If I just write
like,
my
if
own
you didn't use the ready-made
okay,
function sort.
I can write my own sort, but we can just not to time. Okay, for example, selection sort Java. Just took the first solution, which will be here. Okay. Okay, so we want to return it. Okay. And return array. Okay, let's see. It's really interesting. Okay. Two string array. Oh, yeah. The third one is sort. So more or less, it somehow gets it, but it's not perfect, as you see. So yeah. Why does it think it's a string type, two string array? Yeah. Yeah, more or less it's it. So this one is first demo I want to show you. Second one is CodeBERT. So BERT is, as I already told you, famous model for natural languages, and it is also trained for codes. And yeah, now I will show you really interesting thing. For example, imagine this is a code and this function name is masked here. So what we do is we ask for model to fill this token. So if we just go it will generate. Okay, maybe it takes so much RAM. Okay. Hope it will finish. Okay, let's run it again. So this one should not need this much time. This one is, yeah, we still have one. Okay, so yeah, maybe before it just executes, I can show you second demo. So second demo is that so I saw pre-trained model which takes the code and outputs actual comment for it. So if we just go down here, or maybe it just needs okay, just restart it. Okay, so let's run it again. Maybe it just needs. Okay. So yeah, we can go here before that. And for example, imagine code is like this, and we ask model to generate what is a comment, what could be comment for this function. And as you can see, it takes 2 arguments and returns maximum. So let's see this one. So this one is I just wrote add or divide, so it takes a and b and one Boolean function, Boolean variable should div, and if it should div, it returns a divided by b, else return a plus b. Okay, third one. This one takes string, creates new string out of it, and returns vice versa, so reverse string. So if we run it, it will returns the reverse of a string. Third one is Fibonacci number written with recursive way. If I just run it, it's Fibonacci. I do not know if Fibonacci is a different person, but I think it just misspelled it. But more or less, it just can understand that it's Fibonacci. So this one, maybe you can you thought that this is because you also name a function with meaningful string, so it can generate the meaning out of only this name, I will just call function. Now it takes array and search element and counts how many times element occurs in this array. And if I just run it, it will generate count the number of occurrence of a search element. So it's interesting. Also, this one is just random code for internet, which just connects to internet, so connects to server with sockets, using sockets. And yeah, it generates connect to server. This one just checks if a concrete string is ASCII type. It checks if your string is in code. This one is just function for calculating the gradient in machine learning, and yeah, function to compute gradients. This one is forward passing, and it returns perform forward pass through the network. And this one is the actual code which I have here, and so it's just building pre-trained model. And yeah, it's just not building actual loading, and it can really understand that, says that it's loading pre-trained transformers, and it not only knows that it's a neural network, but it also knows that it's a transformer. Okay, before I go to this CodeBert demo, do you want me to try something with this? Because it's really interesting what will it output. So do you have any ideas? Okay, then I'll go to this model. Okay. 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 Yeah, now it returns, it works in a good way. So I masked this word and asked model to predict what could be the word, and just going through this code, it just understood that this function returns maximum out of two numbers. So it put word maximum, max, here. So this is just same code but written in a different way. So it still returns, it still puts mask. So it's the same code but written in Java, different language. If we go, it still puts max here. This one is Fibonacci number, Fibonacci function, also written, and here it's masked. So it's interesting if it will be able to put Fibonacci here. Yeah, it is. Now, for example, we call function add. It takes A and B and masks this token here, and we can say that because the function is named add, it means that we should have plus sign here. Let's see. Yeah, it put plus sign here. So in this case, I masked the second argument. So if it's now I want to get if it could understand that addition happens on first variable and second variable, and if I run it, it still puts B here. So if I do it with not B, maybe some people have arguments A and B. Now I call it I, so just to see if it's biased or not, and yeah, it still outputs I. Now I did vice versa, so put I here and waiting for what it will put it here. Yeah, no, this one. So, and now this is interesting thing. So I put my name here and mask here. And one could imagine that Shota should be also here, but it should not be, because as I told you, this model uses token level analysis, so it doesn't know what Shota is and only have to put one token. So it may have Shot and A as a separate tokens, but it should put one token. So that's why it put it Shota here and not Shota, not Shot and not Shota. Okay, so this way I was checking if it also knows libraries. So in this case, if we want to generate return function max, it should be mass.maximum, and it still has. Now I tried for I wrote binary search code, which searches iteratively element in array with binary search algorithm, and assuming that array is sorted. And it generated contains. So more or less it's understood that it's searching, but yeah, it doesn't have token called binary search or something like this, so that's why it generated contains. And here I just put it here. What should be here? I mean, it should be false here. And yeah, now it returns true here. So more or less, it's also understand it. So for example, if I make it int, so I did not make this experiment. So it's interesting. What will it output? Return name. Yeah, it's really interesting that it not only can understand it. So it's really interesting for me because this way, the previous way it was this algorithm. So it was Boolean. So it was outputting true or false, and I was outputting false here. And in that case, it understood that function was Boolean type, so it did not return anything else but Boolean type, and also chose true because it's a contains method. And here I changed the Boolean to int, so it returns. It should return actual index where it finds the element into array. And instead of returning -1 and instead of returning true here, it returned m. And not only it returned integer variable rather than Boolean, but it also realized that it's a actually localization problem. It tries to search for a actual index where you found the element, and instead, for example, it could return 1, 0, something like this, but it returned m. So it means that it can really understand what this function really does. So yeah, more or less. And yeah, one more thing. Now, before we go to Q&A session, there is one. If you are interested in this topic and you want to do some kind of research, there is really good repository on GitHub, which is machine learning on source code, and it has so many papers. Almost every paper which is written on this topic is here. And for example, I didn't mention GNNs, graph neural networks. And if you think of it closely, the best structure that defines and somehow predicts the whole structure of code is graphs. And more generally control flows, because abstract syntax trees does not include all the relationship between nodes. It's just one tree and it's more semantic way. But if you want to do really, if you want to retrieve more information from this code, GNNs are the first choice. So there is so many research on anything. So datasets, for example, so where datasets, where can you find? I also mentioned public Git archive, code search net challenge. So there is so many papers, and yeah, if you are as passionate or became as passionate as I am about this topic, you should definitely check this out. And also why I will now, before we go to the Q&A session, I will explain why I am interested in this topic and why I think it's really interesting. Is that, for example, Microsoft brought GitHub just because it could have access to all these repositories, so it could train models for VS Code and Visual Studio for creating AI assistants. So yeah, the big companies really think of it. So if you have heard about Codex, which is just published by OpenAI, it's, as Irakli also mentioned, model GPT-3. It's trained on GPT-3 on every possible code which is on the internet, and it's really huge model. And I will show you one brief demo if you want. Not mine, because you have to have access on it. But yeah, I'm not sure if I can run videos on this. So, but if you search for Codex demos, you will find it then some demo where programmer just writes actual natural language. For example, put image on the desk, and it just generates JavaScript code which puts concrete image on the view, then tells it to make it move by 5 pixel speed, and it starts moving. So, and not only it generates all this code, but if you use, for example, eat word, for example, make it run, for example, it remembers that it refers to the image which he just put on the view, and yeah, GitHub generated GitHub Copilot, which is really good assistant, which helps you to with code completion. So in 2021, there was not many research on machine learning which outstanded because of this COVID situation. There were really good papers about GNNs, graph neural networks, but more or less research was not as it was in previous years. But the two things that happened that I think is one of the most important are related to actually this machine learning on code, I mean Copilot and Codex, because these two models really outstanded, and it just showed us that you can do really interesting stuff with code. So yeah, more or less it's what I want to say and show you. If you have any questions, please go on. And also if you want to try and play with these demos, you can also try that, because I just ran something, I just changed Boolean type to int, and I found a really interesting subject about it. So yeah, it could be interesting. So yeah, please, I'm here for questions. And I hope it wasn't as bored as I think it is now. Sure.
I noticed that every example was like popular algorithms like adding or Fibonacci or sorting, which all the programmers and these systems know. What about real life situations?
Just, yeah.
For example, you have a list of objects like persons, and you want a person with maximum age.
Okay, let's write it. So which one do you want? So code name generation, comment generation, or masking one?
Anything.
Okay. Let's try them. Okay. Oh, okay. So let's have something like this. Def.
Or if there is code more than 20 lines or something.
I think it has the limitation or sequence length, but I'm not sure how long is it. So let's try it, if it is what you asked.
Okay.
Okay. Yeah, it's a really long name. Okay, so we have array. Okay, so let's have person. Sounds like this, right?
Can you name it something different, like temp or xxx, and then it can guess?
Which one do you mean, temper?
Like function. Can you name function something?
Func. Something like this? Yeah. Okay. Let's see. Find the person. Yeah, more or less. It struggles to catch the logic of finding the with maximum age. So let's have the previous function name with the maximum age. Now it can generate. So it does
not make sense. Like if you know what it does, no, I don't need this comment.
Okay, now let's have different logic here. So let's call them find person with a maximum age, and then check, for example, if array len array is less than, for example, 10, return array 10, something like this, and otherwise return array 0. So I just put different logic. So let's see what it will output. Yeah. So yeah, it's not perfect model, and also this one is just pre-trained model which I just found on internet. So I'm not sure how big data it is trained on. So I know that the base model which is trained on, so it's fine-tuned on is the model code beta I showed you, but in what type of data it is trained and what kind of situation, I mean epochs and things like this, I do not know. But yeah, it's so okay. So it's interesting. So let's try one more thing before we go to the second question. So for example, let's call it find. Yeah. Okay. Yeah, it's not perfect, but it still does some things. As I also showed you here, I was calling functions, and the thing you just described is, and you told me, was that it was outputting correct labels because the code was really famous, because it's more, and the explanation for it is that of course it's trained on some data and it's more likely to have this kind of data more times, and it will be ran more times and trained more times rather than this kind of functions. So yeah, that explains stuff. Okay, please, other questions?
Hi, thank you for this cool presentation. I'm actually wondering regarding your first example, what if you do some string constant, for example, a function that returns string constant, how much would it pick on the string itself and then suggest what kind of name of the function would it be?
So can you repeat?
Regarding your first, so name generation, I guess.
Okay. You mean this one?
Yeah. For example, if you create a function that just returns a string constant, so function does nothing and it just returns a string constant.
Oh, interesting one. Let's try. So does it take some argument?
It doesn't matter. I mean, you could take some argument, but then in either way, you just return a string constant.
Should it be some meaningful name, or I mean, should it be some meaningful string which it outputs?
It could be anything. Just I don't know, return argument or something like that.
Okay. Let's see. ToString. More or less, it's string method get name type def. So as you see, confidence is not as high as it was in previous examples, but yeah, more or less, ToString is. So if I change it to something meaningful, for example, if I return the name of the function, will it change something? Get function. Oh, it's really interesting that if I just named, so let's try another thing. Let's call it foo, and then also return foo. Will the result be the same? Let's see. Yeah. Oh, it gets something. Yeah, more or less, it does some catchy things, but yeah, it still really struggles to just be as good models as it's in natural language. Because yeah, even though we have really big data about codes, it still is not as much as it in texts. For example, if you take GPT-3, I think the difference will be between the text data, which is on internet, and the code data is really huge. So it's 10 times more or something like this from my point of view. But yeah, and yeah, it needs. It's really hard to just. Yeah, even though it's more structured, it's even hard to, because it's really strictly defined. Programming language, it's really hard to somehow get patterns out of it and actually output again. Also, there is so little functions with one line, right? if the repository is 50 stars or more, there is more likely to have, for example, 50 lines or something like this to function. So, of course, as it is also a machine learning model, and it does filling with path tokens. So if the sequence is really small, it needs to add so many tokens to it, path tokens. So it will struggle to find the actual meaning, because most of the tokens will be padding tokens, not actual tokens, which is it. So as large the code is, it's more likely to generate good output of it, as if it's not very, but if it's very simple function which is very famous, it's more likely to generate correct answer.
Yeah, but I think
for the questions.
it's done a good job with the toString prediction. I think because of the most of the toString function, they just take some arbitrary, I don't know, object, and then they return a string representation. So that prediction might have been correct, I guess. Thank you.
Thank you.
Questions? No? Okay. Thank you, Shota, so much.